I'd like to start things off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including the very latest models incorporating new cutting-edge technology. Now, over the years, I would typically start off these presentations with a discussion of the importance of STEM education, talk about changes in the manufacturing environment, and of course, the growing need for highly skilled workers in the modern workforce. But I really think at this time it's pretty well established just why technology-focused education is so important. And so with that in mind, I'm going to pretty much dispense with any preamble about that and jump right into the discussion of what fischertechnik is, and then I'm going to show you each of the current models that are available in the simulation family. Now, fischertechnik simulation models have been designed with the intent of providing a compact, engaging, and a hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines and systems that are commonly found in commercial manufacturing environments. Now, before we begin to look at each of these models, I'm just going to provide you with a little bit of background. fischertechnik has been creating tools for teaching students of all ages how technology works for over 60 years, all based around their unique building system. Now, what makes this building system unique is that unlike many other popular construction systems where the components are designed to simply stack, the mindset behind the fischertechnik system was more engineering based. If you see the core building block that's displayed on the screen right now, it's designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of very different and very specific parts that are available will help technical builders to address equally specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen right now, who's noted for countless innovation used in both the construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Just to give you an idea, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography. This was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. Up until recently, they were also involved in the production of components used in the automobile assembly process, and currently they also provide consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of the fischertechnik building sets, and that's whether we're talking about those sets intended for the retail market, the so-called toy end, or for classroom use, the focus has always been on helping to foster an understanding of education, or excuse me, an understanding of technology and how things work. Now, many of the products offered by fischertechnik for the education sector are what we often refer to as subject-specific sets, and they'll focus on different STEM-related topic areas, things like pneumatics, renewable energies, mechanics, robotics, such and so on. Now, many of these sets will include curriculum or detailed teaching and activity materials, and in most cases, students are going to be asked to build a progression of models in these sets using the unique fischertechnik building system I talked about, and then they perform various experiments which allow them to explore and understand key aspects of the subject being studied. Now, the line of fischertechnik simulation solutions, which again are, of course, the focus of our presentation today, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines and systems. Now, models found in the fischertechnik simulation line include things like conveyor belts, three-axis pick-and-place robotic arms, color sorting lines, high bay warehouse storage systems, and even complete material cycles. Now, besides these individual models, which focus on specific automated processes, fischertechnik also offers several variations of an integrated factory simulation model. Now, these factory models consist of four individual workstations. Most often, you're going to be seeing something like a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, or a sorting line with color detection that are designed to all work together as one self-contained material cycle. And we're going to take a look at these a little bit later in the presentation. Now, before we get into that, we're going to very briefly outline some of the advantages of using fischertechnik simulation solutions. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate in both appearance and in function common automated systems. Again, things like conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop sized, they're not only ideal for use in the classroom or in-office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and I can't stress this enough, is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Now, most of the models in the line are 24-volt models designed specifically for higher education and for industrial users, with select models also available in a 9-volt version for those not versed in the use of PLCs or not focusing on that kind of programming. Now, in the case of the 24-volt versions, they're designed for use with industry standard PLCs. And with that in mind, it really doesn't matter whether you prefer Allen Bradley controllers, Siemens controllers, or if you use controllers from manufacturers like Honeywell, Mitsubishi, General Electric. Of course, the list goes on. In most cases, you can control these 24-volt models with the PLC which you prefer. Likewise, just as you can use your choice of controller, you can also choose from your preferred programming language from the languages that you see listed on the screen now. Now, do note that with many of the 24-volt versions, the models that we're going to be looking at least in the early part of this presentation, there's no PLC that's included, and all programming and all programming-related guidance, as well as any power supplies, wiring from the model to the PLC connection board, or other pieces of hardware would be the responsibility of the end user. So at least early on, what you're going to be seeing are basically the models themselves that will, again, require the PLC, your own programming, your wiring from the model, etc. Of course, this shouldn't be an issue, as these models are again designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. Now, for those who prefer a more inclusive option that includes the PLC, we're going to discuss some of those models in the latter part of the presentation. Now, as I touched on before, there are also 9-volt versions available on select models. Now, in the case of these 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are the robotics TXT 4.0 controllers. And in the case of these, each controller is going to be pre-programmed either using fischertechnik's own RoboPro graphic programming software, or in some cases C, C++, or Python, depending upon the model. Now, typically, the only additional component required with the 9-volt versions will be the addition of one or more power adapters, as will be specified with each model that we touch upon. Otherwise, in most cases, these 9-volt versions would essentially be ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adapted some of the models in the primary line of simulation and training solutions for IoT purposes, doing this on their own, Since then, fischertechnik has also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. Now, in the case of these models, they're designed to be both controlled and monitored from a special web-based dashboard. And going to, of course, take a detailed look at these a little later in the presentation. Now, the final factor I want to touch upon is the fischertechnik simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, what you're going to really notice very quickly is that the entry point for many of these products can easily be $30,000 to $40,000 or even much more. fischertechnik simulation solutions, on the other hand, start at just a fraction of that price. And again, all the factors that we touched upon before, they're compact, realistic, and high-quality learning and demonstration tools. So on that note, let's look at each of the models that are available in the line, and we're going to begin with a look at some of the more basic standalone models, and gradually we're going to work our way up to the larger factory models, which again consist of several individual workstations designed to showcase an entire production cycle. Now, we're going to start off with the classic line of fischertechnik simulation models, and the first model we're looking at there is your basic conveyor belt. And essentially what you have here is you have a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 29 millimeters. Now, if you wanted to, multiple conveyors can easily be connected to increase the length of transport if so desired. Components that you'll find on this model will include an XS motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. The dimensions are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. This slide here, of course, shows the 24-volt version of the model, which has a multi-pin connector. It has 26 pins with a 2.54 millimeter grid, and this will also be the case for the next few models that we're going to be looking at. Now, this and the other individual workstation models that we're looking at, again, require the end user to provide their own PLC, perform any wiring from the model to the PLC board, and of course, supply the power supply, any other necessary components, and of course, create their own programming. The next model we're going to look at is the indexed line with 2 machining stations. And essentially what you have here is a U-shaped conveyor line consisting of a milling and a drilling station along with 4 conveyor belt sections. Components on this model include 8 XS motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and it has a total weight of about 8 pounds. Again, the same 26-pin connector with a 2.54 millimeter grid is used with this model. Please do note that this is a limited production model, which we had specially commissioned by fischertechnik, and it is only available in limited supplies while supplies last. So if this is something you're interested in, please let us know ASAP. Next model we're looking at is a variation on the idea of a pick-and-place robot, or the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. The dimensions are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. Once again, this has a 26-pin connector with a 2.54 millimeter grid, and it is only available in a 24-volt version. The next model we're looking at is the vacuum gripper robot. And starting here, we get to show you the models in action. Now, what you're going to be seeing once the video gets started here is that the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions of the model are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. This model is only available in the 24-volt version. Differing from the previous models that we discussed, though, this 24-volt model, as well as the 24-volt models we're going to be looking at moving forward in the presentation, each have a relay board for motor polarity reversal and both a multi-pin connector, this time 34 pins with the grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user will provide the PLC and the programming needed. I apologize, we seem to have a little bit of drag with the video, but hopefully that will smooth out on some of the future videos. We'll just let this play out for a couple more seconds. And delivered. The next model we're looking at is the automated high bay warehouse. The model you're going to see in this video features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots for the workpieces. Components on this model include 2 encoder motors, 2 mini motors, and 4 push-button limit switches, along with 2 photo transistors, 2 LED light barriers, and a selection of different color workpieces, along with the carrier trays for each piece. The dimensions on the model are approximately 19 by 28.5 by 15 inches, and it has a weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins, with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And once again, of course, you need to provide your own PLC and your own programming. We do also currently have a 9-volt version of this model available, which ships pre-wired to a pre-programmed TXT controller. And in the case of that model, 1 power adapter is required, which we also make available. The next model we're looking at is the multi-processing station with oven. This model features a furnace simulation with a pneumatic sliding door. What you'll see here is basically a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. The model again shares the same 34-pin connector that I described in the previous 2 models, and it is only available in the 24-volt version. Again, we'll just let this play through here. And again, I apologize for the jerkiness of the video image. I think this is related to the update that we are avoiding right now. But in the meantime, the next model in our progression that we're going to look at is the sorting line with color detection. And what you're going to see here is a simulation that features a system for detecting workpieces of different colors and sorting them using a conveyor belt into 3 different storage bins. Components you'll find on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches and has a weight of about 10 pounds. This is available in a 24-volt version, again with the 34-pin connector, 2.54 millimeter grid, as I've mentioned several times. And there is also a 9-volt version, which is pre-wired to pre-programmed robotics TXT controller, and that one would require a separate power supply for that, which we do make available. You can see the pneumatic cylinders here, which help to move the workpieces into the different storage compartments. Now, the next model we're going to look at is the classic fischertechnik factory simulation, and this combines the last 4 models that we reviewed. It combines the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. It combines these 4 models into one self-contained material cycle. And what you're going to see in this video is a cycle that essentially works like this. Work pieces that are stored in the automated high bay warehouse are retrieved using the vacuum gripper robot, and they are then moved to the multi-processing station with oven where they get processed. Now, after the workpiece has been processed by the oven, it is then sorted by color in the sorting line with color detection before again being moved back by the vacuum gripper to the automated high bay warehouse once again for storage. Now, as we've already discussed the components of each of these individual workstations earlier in the presentation, I'm not going to belabor it by restating it all here. But what I do want to discuss are the dimensions of this model as a whole. Now, again, as it combines 4 individual models into one uh, work cycle, it has a much larger footprint. What you're looking at is approximately 39 by 31 by 16 inches, and you're looking at a total weight of about 45 pounds for this. Now, due to these dimensions and the fact that this, again, ships fully assembled, please do note that this model will only be shipped flat as freight on a pallet. The model is only available currently in a 24-volt version, and as with all of the other 24-volt models that we've discussed up to this point, the end user will once again need to provide the PLC, the programming, the wiring from the model to the PLC, etc. And I'll just let this work through another minute or two. And there we go. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for users of the factory simulation model that we just looked at, or a couple of the factory variations we're going to be looking at in just a minute. So basically, whether you want to transport the model or just protect it when not in use, this is really the ideal uh, thing to have. The storage case is again, it's designed to, help to protect that. Now, the case consists of an aluminum case maker profile, and it has plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The way the case is designed is the upper section of the case is partially lined with soft foam blocks in different heights, which will help to cushion the model. And it also has 3 internal zipper pockets for storing cables, workpieces, and other accessories. Now, the lower portion of the case is lined with hard foam, and it's essentially designed so that once the top of the travel case is removed, the model on its board can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches. It has a weight empty of approximately 53 pounds. And again, I do want to stress, please note that even when using the travel case, if you are going to be transporting these models, you still want to always ship these flat on a pallet just to protect the model from any kind of possible damage. Now, the next grouping of models we're going to look at focus specifically on the area of IoT, and these are the Training Factory Industry 4.0 models. Now, this group of models was designed to help address how the recent changes in industrial production, which were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation models, such digitization activities can be simulated, learned, and applied on a small scale before, of course, they're implemented on a larger scale. And now, as the following video provides a narrated overview of how the factory works, I'm going to step back for a little bit and allow you to listen to the narrator going over this. Again, I hope that you don't have the same lag issues. Hopefully that will not affect the audio, but here we go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory.
Let me just back that up, okay.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The Training Factory Industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first in, first out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
So just to summarize a few things quickly, here are some of the topic areas which can be addressed using the fischertechnik Training Factory Industry 4.0 model. You can address training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, the model incorporates several important features not found in the models that we looked at earlier in the review, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera, which is used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. Now, the use of NFC chips in each workpiece enables the position of the workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with each other in the 9-volt setup. Now, in regards to the 24-volt version specifically, while it of course requires a PLC for full operation and control, it also incorporates one fischertechnik's robotics TXT controller. Now, in this instance, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. Now, in addition to the TXT controllers used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM, or pulse width modulation. And they also have push-pull output stages for photo transistors and for buttons. Now, unlike the previous 24-volt models that we've looked at in this presentation, the Training Factory Industry 4.0 includes access to a sample program. Now, in the case of this sample program, was created in structured text format, all based around a Siemens S7 1500 PLC. And this program is available for download on GitHub. Now, of course, the Training Factory can also be controlled using other PLC models and brands once the end user has made adjustments to the sample program. And if so, the source code available needed for that is also available for download from GitHub. Now, all of this information and much more is outlined in the detailed 152-page PDF manual, which can be downloaded from the manufacturer's website, or which is available from us as well upon request. Now, of course, if you want to obtain that or any information, I'm going to provide my contact info at the end so you can make a note of that. And I also want to mention that there are two additional versions of the 24-volt model which are available, and we're going to discuss those two options when we get into the pricing at the end of the presentation. Now, in the case of the 9-volt version of the factory, the control is facilitated through the use of 6 robotics TXT 4.0 controllers. Now, again, all of the programming with the 9-volt version is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly discussed in the downloadable documentation PDF, which accompanies this specific model, once you've done that, you should be able to get started fairly quickly. Now, the 9-volt version will require the use of 3 additional power adapters, which again, we do provide those as well if you need those. One thing I do again want to make clear, whether we're talking about the 9-volt version or the 24-volt version, it is of course also required that the end user, of course, has the ability to access the internet as well as a device or some sort of a tablet or what have you for accessing the cloud-based dashboard. Now, this model also cannot be operated without being able to connect to the internet. I have heard of people who've made workarounds, but the way it's set up, you really need to be able to have connected to the internet. Just to finish things up, the dimensions for this model are approximately 39 by 31 by 16 inches. Has a weight of approximately 51 to 53 pounds, depending on whether we're talking about the 9-volt or the 24-volt version. And as with the factory simulation model that I discussed previously, we do recommend the optional travel case to help protect the model during transport or storage. And that is essentially the Training Factory Industry 4.0 model. Now, the next model we're going to look at incorporates the cutting-edge technology that's quickly becoming a part of our daily lives. And of course, by that, I am referring to artificial intelligence, or AI. The quality control with AI system model from fischertechnik is ideal for visualizing this complex subject area in a hands-on manner. And really, it helps to create a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation can be standardized. This cutting-edge variation of the fischertechnik sorting line comes with workpieces in 3 different colors, red, white, and blue, much like we saw earlier with the color sorting model that we looked at. But in this case, each of these workpieces are also marked with 3 different processing characteristics and possibly with various fault patterns. The workpieces are first placed on the conveyor belt. The conveyor belt will then, of course, start to move forward, and we'll pause briefly so that the workpiece can be scanned by the camera. And this is where it's classified with the use of the trained AI. The conveyor belt will move once again, and depending upon the color, the feature, or the fault pattern that the AI has observed, the workpieces are then sorted either by color, red, white, or blue, or placed into a discard area after they've been labeled as defective. Now, as with the previous color sorting model we examined, this one also includes a pneumatic element, as you can see from this photo. And the AI used is realized with the aid of machine learning in TensorFlow, where an artificial neuronal network has been trained with image data. The learned AI is executed on the the fischertechnik TXT 4.0 controller shown here, and the model's sequence control is implemented in the RoboPro coding programming environment and as well as in Python. Now, if you want to take it a step further, you do have the option of generating your own AI applications, and if you were going to do so, in this case, the training would be done in Python, for which a sample project is provided to provide an explanation. And that's essentially the quality control with AI model. It's an ideal training, simulation, and demonstration model for education, research, and for the visualization of AI systems, machine learning, and neural networks. Now, this is the rare instance of a model where it is only available in a 9-volt version and not in a PLC controllable 24-volt version. Now, as this model again uses the fischertechnik Robotics TXT 4.0 controller, one power adapter would be required for operation. It's sold separately, but again, we do have those. Now, the next model we're going to look at is the Agile Production Simulation, which is the latest variation of the fischertechnik factory, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also the element of AI. This model also includes access to a digital learning platform along with a digital twin of the APS to further enhance the educational value. The Agile Production Simulation, or APS, was created to service the needs of forward-thinking companies who rely on automation, modularity, artificial intelligence, and agility to remain competitive. Now, in order to help promote these topics in industry and research, students, apprentices, and employees will all require a clear understanding to enable them to deal with these complex issues. Now, the APS model helps to simulate processes, again, things like quality assurance using artificial intelligence. It simulates the functioning of driverless transport systems, and it replicates automated processes on a small scale, from goods receipt to modular production to quality assurance. The accompanying learning materials with this set help to translate the hands-on simulated processes into future skills for both students and teachers. And the digital twin of the model significantly intensifies the overall learning experience. Now, while I will share a video of the APS model in action, let's first take a quick look at the individual workstations. Now, first up is the delivery and pickup station, sometimes referred to the DPS. And this is, of course, where the material flow of a workpiece begins and it ends. The raw material is delivered at the goods receipt slot, positioned on the color sensor for quality control using the 6-axis robot with a vacuum gripper. To date, the previous robotic arms we've seen were all 3-axis, so this is also a new feature worth noting that's specific to this model. So the workpiece is again put on the sensor and encoded by the NFC reader. The robot then places the workpiece onto the back of the automated guided vehicle, or AGV, for further transport around the factory floor. Now, this module also contains the central control unit, which is a Raspberry Pi, along with the environmental sensor, which measures the different environmental conditions of the factory. And there's also an integrated movable camera at this station, which can be swiveled in 2 axes to provide an insight into the entire factory floor via the fischertechnik cloud-based dashboard, again, which we saw an example of in the previous factory video. Now, at the end of a work cycle, a finished workpiece is also delivered back to this goods dispatch station by the AGV. So essentially, this is where the workpiece begins and ends its journey. The next stop for a workpiece after goods receipt is usually going to be the high bay warehouse, although because this is an agile production simulation, that could differ if there was a need for doing so. So the order of processes can be changed, or certain processes can be eliminated or repeated, what have you, because again, it's agile. In any case, the high bay warehouse contains 9 slots for workpieces. It has a stacker crane, its own stacker crane, and its own vacuum gripper that picks up the workpiece from the back of the AGV at the docking station, hands it over to the stacker crane for storage. The workpiece is then placed in a workpiece carrier for storage, and the retrieval is done according to the first in, first out principle. Other workstations the AGV can bring the workpiece to include the drilling station, or did we stop the drilling station? Yep, we skipped ahead. The drilling station, the milling station, and the quality assurance with AI module. Now, as we saw at the high bay warehouse, each of these stations has its own vacuum gripper to help move the workpiece from the back of the AGV and to move it onto the conveyor belt that's at each of these stations where the work process takes forth. And then again, this vacuum gripper will move the workpiece when the process has been completed back onto the back of the AGV for further transport. Now, the AGV transports the workpieces from one workstation to another. It's essentially a track-bound vehicle that follows the printed black tracks that you see on the factory floor here in the photo. It uses ultrasonic sensors to help detect obstacles that may be in its way. The vehicle has omni wheels, which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle to dock to the individual workstations. The AGV receives its driving commands from the central control unit, which is an industry standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, when the battery on the AGV runs low, the AGV will navigate towards the charging dock, where it is automatically charged with a charger with charge monitoring. What happens here is contacts on the bottom of the AGV connect with the charging station to enable the charging to occur. Now, at this point, I'm going to step back once again and allow you to watch and listen to the following video, which will provide a more in-depth overview of the APS.
Welcome to fischertechnik. Experience the Agile Production Simulation, an interactive model that realistically depicts modern production processes. Agile Production Simulation, or APS, combines classic manufacturing processes with digital control and intelligent networking. From goods receipt to production to delivery, every step is automatically controlled, monitored, and documented. The system is based on real industrial components in miniature format: sensors, conveyor technology, robotics, all precise and functional. The dashboard can be used to monitor production at any time, execute order processes, and carry out simulation games. The simulation is perfect for education, study, and training. Ideal for vocational schools, universities, and industrial companies. Complex topics such as lean production, agile manufacturing, batch size 1, condition monitoring, and predictive maintenance are clearly conveyed. The focus is not only on technical aspects, but also on economic and organizational aspects. The included digital learning platform integrates didactic accompanying materials with step-by-step instructions, as well as the digital twin. The individual modules are integrated into a higher-level control system via interfaces such as MQTT, OPC UA, or REST API. Connection to ERP or MES systems is possible, as is real-time visualization. This allows process data to be recorded, analyzed, and used for optimization in line with Industry 4.0. The system has a modular design and can be flexibly expanded to meet the requirements of your training environment. Whether manual interventions, automated quality controls with artificial intelligence, or varying production processes, everything can be customized in just a few simple steps. This makes every training situation realistic and tangible. It is also important to provide learners with didactic guidance so that they can learn in a targeted manner in selected subject areas. Together with the Karlsruhe Institute of Technology, we have developed the aforementioned digital learning platform, which contains 4 specific learning modules on the topics of agile manufacturing, the Internet of Things, artificial intelligence, and automation. In the spirit of a consistent learning journey, each learning module begins with a theoretical section. This is followed by a practical section and a transfer task. The digital learning platform is based on a digital twin of the physical plant into which the learning modules are integrated. Also integrated are a production workflow, planner, and a dashboard of the most important production metrics, such as overall equipment efficiency and throughput time. These tools can be used to solve the tasks within the learning modules. The Agile Production Simulation from fischertechnik, your practical learning system for the smart factory of tomorrow. Innovative, flexible, comprehensible.
So moving right along, I'm just going to quickly review some of the technical specifications of the model. It's a 24-volt power supply unit with 11 amps. The central control, again, is via the Raspberry Pi 4B. The individual modules are controlled with the help of 5 SPS Siemens S7 1200 PLCs. So again, if you paid attention to that video, you saw that each of the stations had its own PLC connected. So again, that's the case. This will ship with the Siemens PLCs attached. Additionally, the model includes 3 fischertechnik TXT 4.0 controllers, which are used to control the sensors in the camera, as well as to facilitate the cloud access in the WEWA module for quality assurance with AI, as well as for the automated guided vehicles. There is, of course, the WLAN router for the WLAN network. The software used on the APS model includes SPS programs and structured text for the PLCs, TypeScript for central control of the Raspberry Pi, Node-RED for communication between SPS and the fischertechnik TXT 4.0 controller, Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning in the quality assurance with AI module. Now, as there's a lot more detail to cover on this model and a lot more to show and talk about, if you would like to know more, I strongly encourage you to sign up for our companion webinar, which focuses entirely on the Agile Production Simulation model. But for now, this gives you an overview of the APS. Of course, if you're interested in the other webinar, please visit our website. You'll see a sign up page for that. Now, of course, you might be wondering how much these models cost. So at this point, let's take a quick review of each option I've discussed along with the pricing for them. The first model we're going to look at is the conveyor belt, the 24-volt version only. The cost is $459.95. Again, you have to provide your own PLC and programming for that. The indexed line with 2 machining stations, as I mentioned, this is a special order model. This is not available elsewhere in the world. We're, I think, the only ones who have it at this point. It is only available in the 24-volt version. The cost for that is $1,379.95. Again, you need the PLC and the programming. 3D or 3-axis robot, only available in the 24-volt version. The cost for that is $1,249.95. The vacuum gripper robot, also a 24-volt only. The cost for that is $1,479.95. The automated high bay warehouse, the 24-volt version, is $1,799.95. The 9-volt version, which comes with the TXT 4.0 controller pre-programmed, cost for that is $1,318.95. The multi-processing station with oven, 24-volt only, $1,479.95. Sorting line with color detection, 24-volt version is $1,387.95. And I believe we still have access to a 9-volt version. That is $1,128.95. The factory simulation. Currently, I guess we only have the 24-volt version. I do not believe there is a 9-volt version on that at this time. And the cost for that is $6,479.95. Again, you have to provide the PLCs and the programming as you would for everything we've looked at so far. Next up, though, Training Factory Industry 4.0. 2 variations on this, the 24-volt version. Again, you provide the PLC. $11,099.95. Again, there is the sample program for this in structured text designed for the Siemens S7 1500s. So if you're going to use it with other PLCs, you would have to make modifications to the programming. Of course, if you're going to use a different programming language, you have to do that on your own. The 9-volt version comes to the pre-wired robotics TXT controllers. Those are pre-programmed. The cost for that is also $11,099.95. But we do have some new variations on the Training Factory Industry 4.0 in the 24-volt version. As I touched on earlier, there is a version that has the PLC connector board and all the cabling. So that wiring that I often talk about is included with this variation along with the PLC connector board. The cost for this variation is $15,734.95. Again, you still have to provide the PLC here. But the next variation takes care of that. The variation of the Training Factory that includes the Siemens S7 1500 PLC. The cost for that, you're looking at $24,049.95 for educational customers, $24,439.95 for commercial customers. So basically, again, those two additional variations with just the PLC connector board and the wiring, $15,734.95. Or if you want to get the whole version with the Siemens PLC, the S7 1500 pre-connected, again, your costs are $24,449.95 for education, $24,439.95 for commercial customers. Other items that are available, the power adapters that I keep touching upon, those are $12.99 each. These would be for use with the 9-volt models. The travel and storage case that we looked at, which is used for the factory simulation and any of the Training Factory Industry 4.0 models that we looked at, the cost for that is $1,849.95. The quality control with AI model, this is again only available in a 9-volt version. Will require a power adapter with that, and your cost for that is $2,589.95. The Agile Production Simulation. This is again 24-volt only. It comes with 5 Siemens S7 1200 PLCs included and pre-attached, pre-wired here, along with 3 fischertechnik robotics TXT 4.0 controllers, all pre-programmed, pre-wired, along with the digital twin, the digital learning platform. The cost for this is $35,174.95. There is also one more item to cover very quickly, and that is the storage and transport case that is designed especially for the Agile Production Simulation model. Now, as the APS model is obviously a pretty substantial investment, this is a great option to help protect the model when it's not in use, of course, if you ever need to transport it safely. The case for the APS is a much larger 2-tiered variation of the case that we previously looked at for the other factory models, and this is designed to house the various components and modular sections of the APS model when not in use, or again, when in transport. Again, as we recommend with all factory models and with the new model, when you use the storage case or not, these models should only be shipped flat on freight on a pallet to avoid any damage to the models when you are moving them over long distances. Just to back up again, the case has an aluminum case maker profile. It has plastic plates. Each of the 2 separate case sections has steel tilt handles and angle protection corners for additional stability. Now, there are also, just as there were with the other case, there are straps and internal zipper pockets for storing cables, cords, workpieces, and other accessories. The lower section of each case is lined with hard foam, while the upper sections have softer foam to help cushion the various work modules while in storage. And the cost for the case is $4,024.90 per unit. So wait, there's more. There's a couple other things to mention. We now have a standalone 6-axis robot. This is available in 9-volt version. This would, of course, come pre-wired to a pre-programmed robotics TXT 4.0 controller. 6-axis robot. It is only available in the 9-volt version at this time, and the cost for that is $1,849.95. There is a new 24-volt model called the production line. This includes a PLC programming course and a digital twin. 24-volt version only, you will have to provide the PLC and the programming, and your cost for this is $2,034.95. And there is also a bending machine, 24-volt version. Again, it includes a PLC programming course and a digital twin with this. Again, you provide your own PLC and your programming, and the cost for this is $999.95. There are a couple of add-ons for the APS factory that we looked at. The first is an additional AGV, automated guided vehicle, that you can add to the factory floor. So you could have two automated guided vehicles working the agile production simulation at one time. The cost for this is $2,589.95. It is designed only for use with the APS and not as a standalone model. There is also an add-on module for the APS factory. This you could add to the whole work cycle, and this is an annealing furnace. Again, you provide, or actually, I'm sorry, the PLC is included in this case. So there you go. You have the PLC and the programming here. So you just need to add this to your APS model. Cost for this is $4,439.95. So at this point, I haven't seen any questions come up, so I think everything is good. So let me kind of just tell you how you can proceed at this point. If you would like to request the higher education and industry guide and the current price list, if you'd like to ask any questions directly, if you'd like to request a quote or speak with your dedicated educational representative, you can do all of those things by calling us directly. Our number here in the US toll free is 888-561-7521. If you have any general inquiries about any of this, just need a quote, you need to find out about a specific model, you can either email us at info, I-N-F-O, at Studica, S-T-U-D-I-C-A.com, or if you have a question for me specifically, either addressing anything that I talked about, that you wished I talked about, any fischertechnik items that are either mentioned here or other fischertechnik items that we offer that you'd like to know something about, you can email me directly, lance.zurek, so that's lance.zurek at Studica.com. In any case, I want to thank you again for taking the time to attend today. I thank you for dealing with our little interruptions and jerkiness with the video, and we look forward to hearing from you soon. So take care and have a great afternoon.